Hope there's no more echo. I will relink it. Technical issues. Can anyone confirm? Hello. Can anyone confirm my voice is better? No echo? Yay, okay. Nice. Alright. I also need to install drivers because I reinstalled Windows recently, and my mic driver is somewhere to be found, and it's only from the Raisin Siren like maker site. I need to register the product and stuff like that. It's weird, annoying. I need to find the packaging and stuff. So it's annoying. But anyways, we can start with the lesson finally. So today's lesson is design patterns, and I would like this to be as a dialogue. I would like to talk with you guys. So does anyone know any design patterns? What design patterns do you use? And how often do you use them? Or is design patterns like a completely new thing for you and you've never had an experience with it? Dry is not a design pattern. Basically, a design pattern is a combination of best practices, but it's a specific, application of them, a set of classes. You basically solve a very specific problem, and you can create a class diagram for that problem, and then only small details will change from one solution to another applying that design pattern, but the structure, the design will be the same. Builder pattern, Singleton, observer, and many others are all valid patterns. There are 23 design patterns in total, at least based on the original sources. Gang of Four was the first group of developers who created it initially. The coined the whole term design patterns. The head first book is good. Yeah, it introduces those things. Strategy, Factory, and Decorator are nice patterns, and I agree. I use them. Maybe I don't use Decorator as much because, well, we will see. We'll see. I might talk about both parts or just one part because I have two slides, two parts already ready. So I don't know if I should talk about both now or just one. But this should take like 1 hour to do. So I don't know. We'll see. So let's start. Well, in general, design patterns are basically a set of classes which have a layout, a design for solving some very specific problems. And each pattern solves its own problem. Adaptation of patterns are possible. You should never apply it just as it is. You should always adapt it in one way or another, like naming it better. Don't call classes like always a factory, always a wrapper, always an adapter. Just call it what it is. Maybe it is an adapter, maybe it's not, but call it what it is. You don't have to call stuff by the pattern names. Anyways, let's continue. So the most easy to understand design pattern and the most commonly used, I mean, maybe not the most commonly used, but quite commonly known is Singleton. Singleton solves a problem that a class needs to be called globally. So for that purpose, we write static class so that we don't need to create an instance and we can call it globally. But with static class, we don't have inheritance. And with static class, we cannot, let's say, put a static class under an interface. So those are the two main problems for a static class, that it doesn't have essentially object-oriented programming semantics. Singleton solves that. Singleton basically has a single instance across the whole program. So Singleton has to ensure that there's only one instance for the whole class. That instance is static, and that instance will be only created when it's needed. So lazy loading, static global instance, and once. It will be created once. And what do you guys think? How can we achieve something like creating a single instance once? How can we lock it from being created from the outside? How can we ensure that nobody will create it from the outside? What do you guys think? Yeah, private constructor. With private constructor, you basically limit a getter of an instance to create itself when you need it, to create a private instance field to be created when public instance getter will be called, if it's not already created. And without a public constructor, you cannot create a singleton from the outside. So singleton is a really nice thing. Some people consider it anti-pattern, but when you need to have a dependency on a singleton when it's quite complex, when it has a state, then it should be a singleton and not a static class, because instead of having multiple static variables, you will have one, which is the instance, and all other things will not be static. So it's much easier to manage the state like that, and it's much easier to test it. So here's an example of a logging service. Audio controller is a good example. Audio controller is indeed a good example because for games, for example, you have a soundtrack across scenes, and then when you switch a scene, sound fades in or fades out. There is a crossfade where one sound is getting higher in volume and the other sound is getting lower in volume. So that's this only achievable by having a global state for soundtrack, and then you mix the soundtracks. BMOS asked, am I going to show code example? If you want, I can do it live. I haven't prepared code examples because the examples are fairly simple and the diagrams show it, I think, enough. I can show if you want. I can code it if you want. Okay. So after the lesson, please pick a few patterns that you liked, or pick a problem that you think might be solved by a pattern. Maybe better pick a pattern that you like, or a few, and I'll try to figure a problem based on which a pattern could be applied and solve that problem. So logging service, here we have a static logger. The whole thing why this is interesting and useful is because I am able to inject a logger when creating a logging service. And I can also mock logging service away with all the dependencies that it has. So my logging service will have a log method, but inside it, it will have a non-static logger. Usually when you have loggers, it's a static class which holds it because it needs to be accessed globally. But with Singleton, you can have a non-static logger. In a case where you wouldn't use a static class, it also works perfectly fine. The problem with static class is that you cannot mock it away, and if it has more than one dependency, it will be a bit annoying and problematic, I guess. Command is another pattern. What is the arrow coming out of the logging service back into the logging service? So it basically means that I have an instance to itself. Logging service holds an instance to logging service. I forgot to rename the constructor and instance. Instance, it says, is of type logging service. Instance is of type logging service, and I create logging service. So another pattern is command. Command pattern solves a problem where you have many actions, many complex actions, unrelated actions, but you want to have a unified way how to execute them. So how can you achieve it? You can pass all the arguments from a constructor of a command, and you execute commands. What do you do with commands? You execute them. Command might return something, but it usually should not. But the thing about commands is if that you have a certain group of commands, they should all do be executed the same way. In my case, I can stack the commands, command 1, command 2, command 3, and so on. And I execute them by not returning anything. They can use different input, but that input comes through different constructors. So what problem does it solve, and why do we need it? It solves a complex behavior separation for unrelated actions, and at the same time it provides a unified interface execution. So what do you think is one of the best examples for command pattern? Can anyone give an example for command pattern? I wonder, will you give the same one that I prepared? Someone also said, Dragon Nash said that, Karsh said that Singleton causes many problems, but you can make a Singleton with a lock, within the instance getter, you can lock the instance. Yeah, so I don't know what you mean, because it, as there are solutions for it, and actually with a static class there would be more problems, because every time you access something you would still need to do the same across every single instance, every single static variable, and now you have a singleton, so you have a single instance that you need to manage, not every single member that it has. So let's see. Okay, so the best example that I can think of about command is a remote controller. You see, we have a bunch of buttons on our remote controller, but we just press them. They send RFID probably signal to the receiver of our TV. and it does some command based on the signal sent. And in our case, in this case, execute would be sending a signal for the TV with the command that we have. So turn off TV, volume down, volume up, turn on TV, use input. All of those are commands which are executed the same way. You press a button and it does something. So button would be really easily linked to a command. It's really easy, the other way around. It would be super easy to link a command to a button. There could be some cool use of applying that and strategy. The command pattern seems to be use polymorphism. It uses polymorphism in a sense that you do execute different things in the same way. Tolerable Streamer said that it could be combined with strategy, and I don't see that happening that easily unless you mean that a different command could have different ways of being executed. Like there is a different strategy to execute a certain command. For example, volume down could have different algorithms how volume is being put down. Then I could have, here more child classes which derive from volume down. And like this, I could make strategies for how volume down is done, or for how I use input. Use input is actually an interesting button. Imagine a button like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So you build a command by passing an input object, for example 1, and when you execute, you send 1 to the receiver, and it accepts it, it eats it, and let's say goes to channel 1 or writes inputs 1